exam, so I won't be able to join.
Okay. Okay, so
Ma'am,
let's
for
start.
me, I'm getting till measurement of delta H. Till there it's coming from.
Okay, till delta H. Okay,
Yes.
okay, it's included means bomb calorimetry, and that part is included here. Okay, so let's start the session. Okay, so first topic is reversible or irreversible process. So there are two types of processes, reversible or irreversible. Okay, so we will understand each and every topic in very details. So reversible process. So what is reversible process? So process whose direction can be changed at any stage. For example, let's take suppose it's a container. Suppose it's a container, and here the gases are filled. In a container, gases are filled, and here यहाँ पे piston लगा है. Piston is there, and here are some weights. Some weights are here on the piston. यहाँ पे एक weights लगा है, बहुत सारे small weights. These are some weights. Okay. Now this is a P external. External pressure has been applied. Okay, and this is the P internal. P internal. Now what happens over here? This now suppose this is in equilibrium. This system is in equilibrium. Equilibrium means the P external should be equals to the P internal. Pressure inside will be equals to the pressure external pressure. Then only it will be in equilibrium. Okay, so suppose this is in equilibrium. Okay, now if I remove if I remove this one weight from here, let's remove it. So what will happen? What will happen? The volume of the gases will try to expand. Gases will try to expand because here the pressure, external pressure becomes smaller. Okay, as compared to P internal. Starting में क्या था initially? It was an equilibrium. Means the P external is equals to the P internal. Okay, due to this weight, this weight. So when I remove one weight from this piston, so what will happen? The gases inside this container will try to expand. ये और भी expand करेगा means inside the container volume will increase. Volume of gases will increase. They just try to occupy more space, okay, due to the less external pressure. Due to the less external pressure. Now, what happens over here? So here, when the volume increases, so what will happen? See, the pressure inside will reduce because volume increase कर रहा है, gases are expanding. Gases are expanding. So here, pressure inside will also decrease. Pressure will also decrease. Means when the volume increases, when you remove one piston, then the volume of gases will increase. Why it will increase? Because the gases will expand. Will expand. When they expand, so obviously the volume will increase. Okay. And at that position, the P internal also reduces. Why P internal also reduces? See, because this is a container and the volume of gases or expand होगा. अगर और expand होगा means the particles of the gases are very far away from each other. Okay, the molecules of gases are very far away from each other. So that's why the gases are expanding. So if the gases are expanding, volume increases, and if volume increases, the pressure inside will decrease. Will decrease. So again, this process will be in the second stage. This process will be in equilibrium because again the pressure external will become equals to the pressure internal. So that's a case of reversible process. So reversible process is that in which the equilibrium will be maintained at every stage. At any stage of the reaction or a system, the equilibrium will be maintained. Okay, so suppose in this case, what happens? The pressure, the volume inside increases. Okay, and This is the piston over here. So what happens? There will be a, when you remove one weight from here, what happens? The P external में से कुछ minus हुआ है. There will be a little change. Okay, and small change को आप कैसे denote करते हो? dP. Okay, a small change in the pressure. So basically, in what is the difference between dP and delta P? So delta symbol we use for a large change, for a large difference. But the D, a small d, we use for a small, very small changes. Okay, very small difference के लिए हम dp use करते हैं. So here the P external will become P external minus dp. Okay, because when you remove one weight from here, okay, so what happens? The P external क्या होगा? Decrease होगा. So that's the decrease. Okay, dp. Now what happens over here? So P internal always also P internal will be, and now in this case also it will be equals to Pi equals to P external minus dp. Okay, because again, because P external decrease हो रहा है, तो again P internal will also decrease. Why it will decrease? Due to the expansion of gases. Due to the expansion of gases, volume increases, and if volume increases, it means the gases are very far away from each other. Means वहां पे pressure कम है, pressure कम हुआ है, right? So overall, you can see it's again in the equilibrium. It's again in the equilibrium. So that's the case of reversible reaction. That's the case of reversible reaction. It means that equilibrium will maintain in each and every stage of the reaction of the system, you can say. Got my point? Neha, Zainab, Sanidhi, is it clear, bachcho?
Yes, ma'am. Yeah, ma'am.
Yeah, so see, and this reversible process is those process in which the direction can be changed at any stage. किसी भी stage पे direction change हो सकती है reaction. So that's a reversible process. Okay, so first point. And what is irreversible process? The process whose direction cannot be changed at any stage, right? And here, yeah, second point is the driving force is only infinitesimally greater than opposing force in the reversible reaction. Now, what does this mean? इस sentence का मतलब क्या है? Now, for this, you should know what is driving force and what is opposing force. So, driving force is those force due to which the process will occur. The process will take place. Okay, like just a opposition party क्या होते हैं जो oppose करते हैं? That tries to stop, okay, that tries to stop, and they due to that opposing force the reaction won't take place, or the reaction will stop, right? So these are the two forces. So here in this case the driving force is your P internal. P internal is the driving force, and your P external is the opposing force, you can opposing force. Okay, because here P internal uh, tries to basically, here the gases particles are there. Okay, the gases will try to expand. Okay, and रोक रहा है इसे P external, which is a opposing force. Okay, which is a opposing force. So here in the reversible process, the driving force is only infinitesimally greater than opposing force. Okay, so the driving force is infinite greater than opposing force. Okay, बहुत ज्यादा difference होता है there in the difference between PI, internal pressure, and the external pressure, right? So driving force is greater than opposing force here, so that's why it is reversible process. So just remember reversible process, but at equilibrium, because each and every step will follow the equilibrium, so a pi will equals to the P external, right? So here you can say this is a pi, P internal, but this is a P external minus dp. So यहाँ पे से कुछ minus हो रहा है, subtract हो रहा है. So that's the equilibrium, and that's why the pi, which is a driving force, is greater than the P external, which is the opposing force in the reversible process. Got my point?
Yes.
Okay, let's see what about the irreversible process. suppose this is your, so let's make the partition over here. So this is the reversible process diagram and this is the irreversible process. So what happens over here? This is the again the container. These are the gaseous particles. This is the piston over here, and here there are some weights. In the irreversible process, you will only initial. It depends on the initial and the final stage. Okay, initial and the final stage. So equilibrium will be maintained at initial and the final stage. बीच का कुछ नहीं पता. Okay, बीच में in the between stages, okay, in the intermediate stages, the equilibrium will not be maintained. It will only depends on the initial as well as on the final stage. So these are some weights. Okay, this is the gaseous particles. This is the P internal, and this is the P external. Now, what happens in the irreversible process? It's a rapid process. It's a rapid process. So what happens? This was in equilibrium. Initially, क्या था? Initially, it was in equilibrium. Means Pi will be equals to the P external. Okay, internal pressure will be equals to the external pressure. Now, what happens? Suddenly, when you remove like 5 to 6 waves at a time, okay, because it's a rapid होता है, step by step नहीं होता ये बहुत ही rapid होता है, this irreversible process, right? So you can see the third point, it is done rapidly. So if it is done rapidly, so if you remove like 4 to 5 waves, 1 2 3 4, so these waves will be removed. So what happens? There will be a sudden shift, sudden decrement in the P external, right? यहाँ पे अचानक से decrement होगा, and what happens over here? There will be a large difference. Okay, now this is the P internal. So what happens when the like 4 to 5 weights were removed? What happened suddenly? So suddenly the volume will increase. Volume will increase. Okay, and yeah. So here P internal, again P internal will be decreased. Yeah, but at initially this is the initial stage. Okay, we will talk about the initial stage and the final stage. We will not talk about the intermediate stage. Okay, so initially and finally the equilibrium will be maintained. And here what happens when you remove 4 to 5 weights? So what happens? There will be a sudden decrease in the pressure, external pressure, and it will be P external minus delta P. Now here the change is delta P, because here's a large change you can see, right? So here the change is delta P, and here the change was dP, means small change in the pressure. Okay, so what happens? So this will become like P minus delta P. So here the again volume will increase suddenly, and it will stop, when P external will become equals to the P internal. Okay, so when there will be a slight or a sudden decrement, large decrement in the P external, when you remove more weights from this piston, right? So what happens? So the P external minus P delta P, ये यहाँ पे बहुत ज़्यादा large changes आएगा pressure में, and here the gases will expand more quickly and the volume will increase. So if the volume will increase, so again P internal will decrease, pressure inside will decrease. So, and this will stop, this reaction will stop when the P external will become equals to the P internal. तब तक ये piston नहीं रुकेगा, okay, जब तक P external will equals to P internal नहीं हो जाता. Okay, means the initial final stage नहीं आ जाता, this is the final equilibrium. This is the final equilibrium. Right? So that's the case of irreversible process. So irreversible process mein there will be a large pressure change, decrement in the pressure. Okay, and here you will study the initial equilibrium as well as the final equilibrium. Now, so at any stage, at every stage of the reaction or any system, it does not, the equilibrium will not maintain in this case, irreversible process. Okay, and here again, the driving force is different than the opposing force. Okay, it's quite different, and difference क्यों आ रहा है? Due to the large difference, in the P external. Okay, so see the difference. So irreversible processes, those process whose direction cannot be changed at any stage. Direction change नहीं हो सकता. It is not irreversible. So unreversible is the process whose direction can be changed at any stage. Here the driving force is different than the opposing force, and here the driving force is greater than the opposing force. It is done rapidly. Reversible क्या होता है? Rapidly होता है. Okay, like a sudden change. So, and this is done in very smallest steps. Very smallest steps. Now the chances when the reaction proceed in very small steps, so the chances of reversibility increases. Okay, small steps में होता है तो chances क्या होता है? Reversibility की increase हो जाती है. But if the reaction proceeds rapidly, so here the chances of reversibility is nil. Okay, so that's why in irreversible process it occurs rapidly, and here the equilibrium is not maintained. Only equilibrium will be in initial and the final stage, not in between. And what about the reversible one? Equilibrium is maintained at all stages. Okay. So here all the natural processes are irreversible. जितने भी natural processes होते हैं, so like burning of wood, okay, anything. So these are irreversible. And but the reversible process, it's a hypothetical process, not it's an imaginary process. Okay, so in real world, it doesn't occur, irreversible process. So it's just an imaginary hypothetical process, but the irreversible process is real, and all the natural phenomena, all the natural processes are irreversible processes. Got my point?
Yeah.
Any doubt?
No, mom.
Okay. Okay, so the next is your internal energy. Internal energy को हम किससे denote करते हैं? Capital U. So what is internal energy? So internal energy is sum of all forms of energy which is stored in a system. Okay, internal energy क्या होता है? Internal energy. Okay, suppose we have a system, any container, and in that container, many forms of energy are stored. Heat energy, any type of energy is stored. So an internal energy is basically it's a sum of all forms of energy stored in the system. But measurement of internal energy is impossible. Okay, how you can sum up all the forms of energy which is stored in a system, right? So it is impossible to measure all forms of energy. So we only study the change in internal energy. Okay, so rather we don't measure the exact internal energy which is present in a system. We measure the change in internal energy, delta U. Okay, and what is the change in internal energy? UF, final internal energy minus initial internal energy. So that's the formula. Got my point?
Yes.
Next is modes of transfer of energy. Yeah, this is important. Modes of transfer of energy. Now, first one is your energy, which is heat. Heat is again a form of energy. Heat and work both are the different forms of energy. So heat is denoted by small q. Small q जहाँ पे भी होगा, it means it's a heat. Now, when you add heat to the system, okay, add heat to a system, and if suppose there is given heat is absorbed. Heat is absorbed. So what does this mean? It means that heat is positive. Heat is positive. Q is positive. Q की value क्या है? Positive. So when you add heat to the system, means when the heat is absorbed by the system, so the heat is equals to positive. Heat की value क्या होगी? Positive. And it means that the heat has been transferred from the surrounding to the system. Heat कहाँ से कहाँ transfer हो रहा है, shift हो रहा है? So from the surrounding to the system. Okay, so that's why heat की value is positive. Q is positive. Okay, this is very important. You should remember this, all this point. So when you add heat to the system or in some questions, अगर दिया हुआ है कि heat is absorbed by the system, so here the value of heat will be positive in a positive form. Okay, and it means that heat is transferred from the surrounding to the system. Second one, if you remove heat from the system, or sometimes ये होता है the heat is released from the system. So release and remove both have the same meaning. It means that the transfer of heat or energy is from the system to the surrounding. System से surrounding में transfer हो रहा है. So if it occurs, so it means the value of heat is negative. There is a negative value of heat. So if you remove heat from the system, so it means the heat has been transferred from the system to the surrounding and the value of heat is negative. Got my point?
Yes.
Okay, work. So work is denoted by W, small w. So work done on the system. Okay, अगर work done system पे हो रहा है, so here the work value is positive. There is a positive value of work if the work done is on the system, and if the work done is by the system से हो रहा है, right? By the system कर रहा है work, so it means the W is negative. Work is negative if the work is done by the system, and if the work is done on the system पे हो रहा है, तो work done is positive. Now, okay, again very important. First law of thermodynamics. So first law of thermodynamics is based on the isolated system. In this, we just talk about the isolated system. Now, what does isolated system means? Yes, neither the heat nor the amount of energy or matter is being transferred. Okay, isolated system में क्या होता है? Means it's properly isolated. Neither from the outside the energy will be given to the system or from the inside. दोनों ही तरफ से transfer नहीं होगा, right? So that's the isolated system. So for the isolated system, we know that Q is 0, right? Isolated system के लिए heat क्या होगा? It becomes 0, and W work done will be again 0. Okay, so in this case delta U क्या हो जाएगा? Delta U will be 0. Okay, so according to the first law of thermodynamics, in an isolated system the energy of system remains constant. Yeah, so it's again important. So in an isolated system, the energy of the whole system, it remains constant. Okay, so you know very well why it remains constant, because you know it's an isolated system. Here the energy, the heat is 0. Okay, the exchange of heat is 0, and the work done is again 0. So here when you put this value 0 plus 0, so you will get delta U equals to 0. Means the change in internal energy is equals to 0. Means the all energy of a system, of an isolated system, has a constant value. Yeah, and this is the equation. This is the equation of the first law of thermodynamics, which states that in an isolated system, the energy of a system. What does this mean? What does this mean? If the energy is 0 and the work is 0, so what does this mean? The energy is conserved. Okay, the energy is conserved. Law of conservation of energy यहाँ applicable हो रही है. Energy can neither be created nor be destroyed. Right? So first law of thermodynamics tells that energy can neither be created nor be destroyed in an isolated system. Okay, so for an isolated system, the energy of a system remains constant. Got my point? And it works on the principle of law of conservation of energy. Clear, everyone?
Yes, ma'am.
Okay. If it is clear, now just quickly do this question. First, express the change in internal energy of a system. Express the change in internal energy of a system. First question. First question, Neha will tell me the answer. Yes, it's no heat is absorbed. No heat is absorbed by the system from the surrounding. If no heat is absorbed means Q is 0. Q is 0. Right, Neha?
Yes, ma'am.
But work is done on the system. If work is done on the system, so what is the value of word, positive or negative?
Positive since work is done.
Yeah, since work is done on the system. It's on the system, so work done will be positive, positive value. So, and here, because no heat is absorbed by the system, so here the transfer of heat is not done, but the transfer of matter or the energy you have a transfer. Work is a form of energy, right? So, so what type of wall does the system have? Which type of wall? Yes, Neha? What type of wall does the system have? Adiabatic, right? Adiabatic के ही case में होता था, there will be no exchange of heat, right? So if no heat is absorbed, okay, so it's a adiabatic system. So the wall of the container or the wall of the system was adiabatic. Adiabatic. Okay, and what about the delta U, the change in internal energy? So change in internal energy is Q plus W, right? And if Q becomes 0 and the value of W is positive, it's positive. So the delta V, delta U की value पे क्या होगा? It's positive. It's positive for the first case. Got my point?
Yes, ma'am.
Yeah, ma'am.
Okay, second. Yes, Zanab, tell me the second answer. No work is done on the system. There is no work on the system, means W equals to 0. But the Q amount of heat is taken out from the system. If the amount of heat is taken out from the system, so the what is the value of Q? Positive or negative? From the system. Means remove कर रहे हैं हम.
Positive?
Are you sure? See this. I just told you it's very important, बच्चे. So when you remove heat from the system, heat is what? Heat is Q, right? So when you remove heat from the system, so the value of Q is negative,
Yeah, yeah,
right?
yeah.
Yeah, so the heat is being transferred from the system to the surrounding. Heat remove हो रहा है, release हो रहा है to the surrounding. Surrounding में release हो रहा है. So if this is a case where the Q value is negative, not positive. If Q value is negative, then what is the value of delta U? Change in internal energy, it's Q plus W. So W is 0. W is 0, but the Q value is negative. So delta U की value भी क्या होगी? Negative. Now tell me which type of wall is here. In the second case, what type of wall does the system have?
Isobatic?
ISO? No. See, no work is done on the system, but Q amount is heat change हो रहा है, but matter transfer नहीं हो रहा है. Right? No work is done on the system. So this is a type of, we have done, I think we have discussed these two walls, adiabatic wall and the dithermic wall. Based on the thermal conductivity, there are two types of wall, adiabatic, okay, and the diathermic. So diathermic में क्या है? Heat exchange is possible. Okay, there is allow of heat thermal conductivity. So it's a, you can see Q amount of heat is taken out of the system. If it is taken out of the system means from this system to the surrounding exchange हो रहा है heat, right? Heat is being released. So it means the wall should be your dithermic. Yeah, it's a dithermic wall. Diathermic wall is those wall in which the thermal conductivity is allowed. So it's a dithermic. Third one. See, this is a NCERT question. It is important. So W amount of work is done by the system, right? Yes, Sanidhi, now tell me, if amount of work is done by the system, so what is the value of W? Positive or negative?
Ma'am, negative.
It's negative. So it's by the system, so it's negative. And Q amount of heat is supplied to the system. So what is the value of Q?
Ma'am, positive.
Yes, very good. Very good. So what type of system would it be? Work is done by the system. System work कर रहा है, and the Q amount of heat is supplied to the system. So this type of wall is known as closed wall. This type of wall is known as closed wall because adiabatic नहीं होगा, diathermic नहीं होगा, so it's a closed wall. Okay. Next question. System absorbs. Yeah. A system absorbs 428 joule of heat and does work equivalent to 286 joule on its surrounding. Determine the value of delta U. Just quickly do that. It's very easy. System absorbs 428 joule of heat. So it's a heat. Q is equals to absorb कर रहा है system. So what is the value of heat? Positive, right? If it is absorbing, so it will be plus 428 joule. Okay, and does work equivalent to 286 joule on its surrounding. Okay, on its surrounding, कौन work कर रहा है? System work कर रहा है on its surrounding. So here the work is done by the system. Okay, here the work is by the system, and if the work is done by the system, so W has a negative value. So it's 286 means to minus 286 joule. Now we know the formula delta U equals to Q plus W. Now put the value 428 joule plus, and this is minus 2 minus 2. 428 plus minus minus 286. So it will give you something, yeah, 142 joule. So what is the value of delta U? It's 142 joule. Clear?
Yes, ma'am.
Ma'am. Yes.
Okay, next one. Yeah, thermodynamic work. Okay, thermodynamic work, and we will just relate the equation of pressure, volume, and work. Okay, we will derive one equation from pressure, volume, and work. So what is the relationship between pressure, volume, and work? Let's see. Suppose we have this container. Okay, this container, and here the piston has been applied. यहाँ पे piston लगा है. Okay, and suppose we are just giving some external pressure. Okay, we are just applying some external pressure. So what happens over here? When you apply some external pressure, over here, so here the gases particles are there, right? So volume of gases will decrease. Volume of gases will decrease. So suppose initially the volume was this VI. VI was initial. Okay. So here, this is the final one. यहाँ से V initial, when you apply some external pressure, what happens? The volume of gas decrease. Volume of gas decrease because of external pressure. So here, external pressure is greater than the internal pressure, right? So that's why the movement किस side हो रहा है? Towards internal, अंदर की तरफ हो रहा है, from top to bottom. Okay, from top to bottom. So this is your VF, V final. First the V internal, this initial volume was this, and the final volume is this after the external pressure, after you apply the external pressure. And suppose, okay, let's draw this like this. Suppose we have suppose this is a piston. ये आपके particles हैं. Okay, and if you are applying P external, Okay, this is a P external. Now again, second step mein what will happen here? Now when you apply pressure, what happens? The volume decreases and आपका piston यहाँ पे. Now this is your final movement. So see, so that is your P external. That is your P initial volume. So see, this is your initial volume. You see the first figure. This is the first figure and this is the second figure. So when you apply P external जब आपने apply किया, the initial volume was this. Here the initial volume was. After applying the P external pressure apply करने के बाद, the volume decreases and volume becomes this BF. This is the final volume. This is the final volume. Okay. So this is the change in volume VF minus VI, which is delta V. Delta V को हम कैसे show करेंगे? Which is VF, V final minus V initial. Okay. Now, what about the length? You can see the length or the displacement you can see. What about the displacement of the piston? So here the piston will displace from here. So see, initially the piston was here. Okay, and after applying the pressure P external, the piston is here. So that's the difference here between this VI and this VF. This is the L. This is the displacement of the piston, right? Clear the diagram? Now
Yes,
let's
ma'am.
see how. Now see, we know that W equals to what is work done? Work done is equals to force into displacement. Work done is equals to force into displacement. Now what is force? Force is a pressure basically. Pressure is equals to force upon area. Force per unit area, it's pressure. So from here, force will be equals to pressure into area. Okay, and because here we are talking about the P external pressure, so we will write P external over here, right? So this is P external. So now substitute this PA. Force is equals to P into A. And what about the displacement? Displacement is just a length, right? So we can write down the L over here. This is the displacement. The piston has been displaced from this position to this. So that's the change. So this is the L. So D के लिए मैं L लिख रही हूँ. Small L is the displacement over here. Now you know that what is volume? So volume is basically area into length. What is volume? Area multiplied by length. Basically length into length into length is volume. Okay, length into breadth into height. All are length, so length. Okay, but when you multiply length into length, you will get area. So volume is basically area into length. The product of area and length is volume. But here we are talking about the delta changes in volume. So we can write delta V equals to area into length. Delta V को हम क्या लिख सकते हैं? Area into length. Now substitute this. This is your delta V. So P into delta V. P into delta V. Now see here. Now see the initial volume, in this case, see the first diagram and the second diagram. The initial volume was this. Initial volume is greater than the final volume, right? So here V final is less than V initial. V initial starting में initially में volume was more. Okay, and after when you give the pressure, P external pressure, so the volume decreases. Means the final volume decreased. So VF is less than VI. If VF is less than VI, then the change will be delta V will be negative. Delta V क्या होगा? Negative होगा if VF is negative. So because you are just subtracting VF minus VI. So if VF is small as compared to the VI, so you will get delta V value as negative value. Is it clear? Why it is negative?
Yes.
Okay. So that's why W equals to minus T delta V. So that's why work done, work. So you can write down W is equals to minus of, what is P over here? P here is external, P external pressure. So you write external pressure multiplied by delta V. So that's the relationship between pressure, volume, and work. This is very important. Clear to everyone?
Yes, ma'am.
Yeah, mom.
Okay. Now let's see this question. A gas absorbs 120 joule of heat and expands against external pressure of 1.10 atmospheric pressure from a volume of 500 ml to 2 liter. What is the internal energy change in the process? What is the internal energy change in this process? It is very easy because we have already derived the formula. W equals to minus P external into delta V. Okay, so see how we can do this type of question. So here gas absorbs heat. Absorb जब करता है heat तो the heat will be positive. When it absorb heat, the heat will be positive 1 plus 120 joule. 120 joule. Now P external value, external pressure is given. It's 1.10 atmosphere. 1.10 atmospheric pressure. And what about the delta V? Delta V. So see here, this is 500 ml and this is 2 liter. Okay, so you have to convert this. So I'm just converting this 500 to liter. So it will be 0.5 liter. Okay, so initially the volume was, this is the initial volume and this is the final volume. So what about the delta V? Delta V will be VF minus VI. It means 2 liter minus 0.5 liter. So it will be 1.5 liter. So that's the delta V. Now you know the formula, just substitute this in the formula. W equals to minus P external into delta V. Now what is P external? So it's minus 1.10 multiplied by your 1.5. 1.5 atmosphere per atmosphere liter. Yeah. So pressure का unit atmosphere and the volume unit is liter. So that's why atmospheric liter. Now see, 1 liter atmosphere is approximately equals to 100 joule. So just convert this into the joule. So you will get minus 1.10 into 1.5 into, instead of this, you will write 100 joule. Okay, just multiply it, you will get, okay, 11 multiplied by 15. So it will give you 165. Okay, and this 120 is cancelled by this. Okay, so basically you will get minus 165 joule. The work here is 160 minus 165. Minus 165. And negative sign kya कहता है? The work has been done by the system. Okay, the work has been done by the system. So energy has been transferred from, yeah. Okay, so minus 165. But the question here is we have to calculate the internal energy change. Delta U की value find करनी है हमने. Delta U. So what is delta U? So Q plus W. And here the Q here is 120 joule. Q is 120 joule plus W value is minus 165 joule. So now just do that 120 plus minus minus 165. So it will give you, yeah, it's 45 minus 45 joule. That's the value of internal energy. Clear to everyone?
Yes, ma'am.
Okay, so each and every point is very, very important. You should know if a gas absorbs heat, so the value of heat will be positive. Okay, and if the work is done by the system, so what will happen? By the system, so the work done will be negative. Okay, on the system, so it will be positive. So these small points will help you to do the numerical very easily. If you know these points, if you remember these points, so the basically this thermodynamics topic is very easy. Or the you can say it's a physical chemistry, right? So यहाँ पे numericals, जितना numericals practice करोगे, it will be more easy for you to do the numericals in your exam. Okay, so just do the numericals from the NCRT, from the previous year questions, and just please learn the formula, because here the formula is more and the concept is more, right? So just revise the formula, revise the concept regularly, so you will get. It's very easy. आप कर सकते हो exam में. So the next one, PV work in reversible process. PV means pressure multiplied by volume. Work, how the PV work in reversible process. So reversible process, again, you know very well. See the diagram. We have already. This is the reversible process, right? So reversible process. Yeah. So let's say at equilibrium, we will derive something here. What happens? Equilibrium में P external, it will be equals to the P internal, right? So here, because we know that in the reversible process, kya tha? The driving force, which is P internal is equals to the P external minus dP. That was the point, right? After the, yeah, see this. See. So what was that? So it was Pi is equals to P external minus dP, right? So that's what we will use here to derive something. So P internal is equals to P external minus dP. Now substitute this value. So P external क्या हो जाएगा यहाँ से? P external, yeah. So P external will be P internal plus dP, right? P external plus dP. So that's what we will use here. Okay. यहीं पे लिख लो आप, just a second. Right here. So here in equilibrium, at equilibrium, P external is equal to P internal. And we know that in reversible process, at each and every step, there will be an equilibrium. It will follow the equilibrium trend. So here, when you remove that weight, so what happens? So P external is equals to P internal plus dP. Okay, before that, you can write this one, that P internal is equals to P external minus D. Okay, so from the reversible process. So after this, you can write this point. So here from here, P external will becomes equals to the P internal plus dP, right? So if it is plus dP, and what is P external? Pressure external. So it will be the change. Suppose there will be a change in the work done. Okay, small change. Okay, because we know that what is the formula of work done? The W equals to minus P external multiplied by delta V. That's the formula which we have derived now. Okay, so we will use that. Now, in a reversible process, we just talk about the small changes. Okay, means the dW. We will talk about the dW, small work done. Okay, small work done. So the dW will be equals to minus P external into delta V की जगह पे हम क्या लिखेंगे? dV. Okay, because we are just talking about the small changes, small difference. So dW equals to minus P external into dV. Now dW equals to, so what is P external? This is the P external. Now substitute the value of P external over here. So P external is P internal plus dP into dV. Okay. Now just open this bracket. So minus P internal into dV minus, plus minus will be minus. So dP into dV. Now see, its value is quite a small, this value. So इसे हम क्या करते हैं? Neglect कर देते हैं. It's negligible. It's negligible. So this value we will just neglect from the equation, and you will get dW is equals to minus P internal into dV. Now just integrate both the equations. On the right as well as on the left side, just integrating both sides. Integrating both sides. So it's dW and negative sign bahar le lo, and it will be P internal into dV. Now just integrate it. So you know very well what is P, what is pressure. So according to from ideal gas equation, PV equals to nRT. You know that PV equals to nRT, right? So from here, P will be equals to nRT upon V. Now you can substitute here P internal ke jagah pe you can substitute this nRT upon V. So here this dW, when you integrate this dW, okay, so integrating dW, so this will cancel out and you will get W over here. And what is W? So W reversible, work of reversible work done, okay, which is equals to minus, and this will give you nRT upon V. Okay, so हम इसे P internal की जगह पे we are just substituting the nRT upon V. Because from the ideal gas equation, we know that PV equals to nRT. So from that, we can use the data into dV. Now you can see nRT, all are basically a constant. Okay, all are constant. So just keep them out. Just minus bahar liya nRT and just integrate 1 upon V into dV. So W reversible will be equals to minus nRT. And when you just integrate this 1 upon V को जब integrate करोगे तो what it will be? It will give you ln V. Okay, and so if you integrate like when you take the upper limit or upper limit, lower limit just V1 initial volume and the upper limit V2. Okay, so V1, V2. There's no space over here. Yeah. So I'm just writing here. Say this. So next step I'm writing over here. So W reversible will be equals to, now substitute the value, range banao. So minus nRT will be equals to ln V2 minus ln V1. Okay, ln V2 minus ln V1. Final minus initial. Now see, so W reversible will be equals to. So this is the formula which we use in the mathematics. So here when ln x minus y, suppose ln x minus ln y, तो इसका formula होता है ln x upon y. Ln x upon y. So it will become minus nRT into ln V2. This is your V2 mine upon V1. V2 upon V1. Now see, what is the relationship between log and ln? So see, if it is ln, so ln is equals to 2.303 log. 2.303 log. So you can just substitute the value over here. So W reversible is equals to minus, when you substitute the value of ln over here, so it will become minus 2.303 multiplied by nRT into, and इसे substitute करके just log V2 upon V1. So that's the formula. That's again the another formula of reversible work done. Okay, the work done in the case of reversible process is equals to minus 2.303 nRT log V2 upon V1. That's the first formula. Now, if it is pressure, so there is another formula. W reversible equals to minus 2.303 nRT log. And here there is a slight difference. यहाँ पे क्या था? Final upon initial. Final log final volume upon initial volume. But here it become reverse. Here it becomes reverse because you know very well there is a inverse relationship between the pressure and volume, right? So here you will write log P1 upon P. So there are two formulas of work. Clear, everyone?
Yeah, ma'am.
Yes, ma'am.
Okay, so this is the derivation. derivation in the reversible process. How PV work, PV and work, between the PV and the work, pressure, volume and work के बीच में क्या relations होता है in the reversible process. So that's we have derived here. So learn this two formula, it's important. Okay, next one. Okay, again I have to write it. Before sharing the notes, I will just check it whether it's, yeah. After this, I think there is no space. Let me just remove this. Okay, here I'm just covering. Okay, so write down adiabatic process. Adiabatic process. So what is adiabatic process? So adiabatic process, there is no exchange of heat. So Q equals to 0. Okay, if Q equals to 0, so we will talk about the W will become W adiabatic. Okay, we just use the term W adiabatic. And delta U, we know the formula Q plus W. So if Q equals to 0, then delta U, the change in internal energy, is equals to the W adiabatic. Okay, adiabatic system ka work done is equals to the change in internal energy. Now, in expansion, in expansion of gases, so in expansion of gases, what happens? The W is equals to negative. W will become negative. So if in expansion of gases, so if W work done is negative, okay, why work done is negative? Because work done is by the system. Okay, work done is by the system. Suppose we have just discussed the reversible process case. So here the work done was by the system. In the second case, okay, what happens when you remove the waste? When you remove the waste, so the gases will try to expand. So when the gases will try to expand, what happens? The volume increases. And यहाँ पे work done किसके through हो रहा है? By the system हो रहा है. Okay, the work done is by the system. So here the work will be negative. So if work done is by the system, so work done will be negative, right? So that's why I've written negative over here. So if work done is negative, so what about the delta U? Delta U will be, because your Q is again 0, because we are just talking about the adiabatic process. So here the heat is 0. So the W will become negative. So it's become negative, right? So if W will become negative, so because you know internal energy change is equals to the work. Okay, if work done is negative, then it means the internal energy change will also be negative. So it means that the internal energy of gas will decrease. The adiabatic system, what happens, the internal energy जो gas की थी वो decrease हो रही थी. It means the temperature of gas will also decrease. The temperature of gas will also increase in the expansion, because every molecules of gases will far apart. Okay, so that's why the temperature वहां पे transformation नहीं हो रहा, the change in transfer नहीं हो रहा है temperature का. Okay, energy की transfer नहीं हो पा रहा, and due to that the internal energy of gas decreases. Why it decreases? Because the temperature of gas decreases. The temperature of gas decreases in the expansion process where the adiabatic process is there. So this process, this is known as, in an adiabatic process, if the work done is negative, delta in change in internal energy is negative. So the your internal energy gas of the internal energy decreases. So the temperature of gas also decreases. And here this process is known as adiabatic cooling. If the temperature decreases, it means it will cool the system. And if it will cool the system, so it is known as adiabatic cooling. Adiabatic cooling. One more point you can write as W is equals to delta U. So work will be, so here work will be a state function, will be state function. Yeah, so here you can see delta W is equals to delta U. Okay, so delta U ki equal hai W. And what is work? State function. A state function was the function that depends on the initial and the final state, not the path function. Not, it does not depend on the path. It only depends on the initial and the final stage. Okay, so if work done becomes equals to the internal energy change, so here the change is final minus initial. So work done also becomes equals to the initial and the final is equals to the change in internal energy. So we can say that here work will be a state function because it is equals to the change in internal energy. Got my point?
Yeah.
Okay. So after this, we will do this question. Yeah. So see here. Let's first discuss, then we will do. I will correct it. Yeah. See this. Now see, it's a container, right? And here the gases particles are present. Okay, यहाँ पे piston लगा है, and on the top there is a piston, right? And here we are just continuously we are just giving heat. We are just giving heat, energy हम supply कर रहे हैं. So now there are two cases. First case is when the piston is rigid, when the piston is hard. Okay, if it is rigid, so here the volume will become constant. The volume is constant because this piston is rigid and it will not move. Okay, when you are continuously giving heat, so the particles will be in random motion. They just try to push. They just try to push the piston in the upward direction. But the piston is very rigid. It's very hard. Okay, so in that case, the volume in the beaker in the container is constant. And this, if the volume is constant, so which type of process it is? So it's an isochoric process. Iso means similar, okay, constant, and the choric volume, right? So isochoric process ye hoga when the volume is constant. Okay, and when the piston is rigid, so it's a isochoric process. Second case is when the piston is very flexible. If it is very flexible, so what happens when you are continuously giving heat as a form of energy? So what happens? All heat is used to lift because when you just supplying the heat, every gas particles are in the random motion. Okay, they just try to pull or lift the piston up. Okay, so all the heat is used to lift the piston up. If all the heat is used, it means the temperature is constant over here. Okay, here the temperature is constant. If the temperature is constant, it means it's an isothermal process. So again, it depends on the piston, whether the piston is rigid or flexible. If the piston is rigid, then the process will be isochoric because here the volume will become constant. And if the piston is flexible, then it will be a isothermal process because here the temperature will become constant. Got my point?
Yeah, ma'am.
Okay. See the next point. In isothermal process, the temperature of the system does not change. So we can say that energy of the system is constant. Energy system ka kya hai? It's a constant. So here the delta U will be equals to 0. Why it will be equals to 0? So if it is equals to 0, because the internal energy change is 0. Internal energy change is 0. because no energy, because the energy of the system is become constant, and temperature is again, temperature of the system जब change नहीं हो रहा है is constant, so energy will be constant. Energy will be constant. So here delta in the isothermal process, delta U क्या हो रहा है, zero हो जा रहा है. If it becomes zero, it means when you substitute the value of zero in this equation, you will get that Q is equals to minus W. Q is equals to minus W. So the heat which is given, okay, or which is absorbed or released is equals to the minus W. Okay, the work done by the system. The work done by the system. Got my point? So this is for the isothermal process. Any question from this?
No, ma'am.
Okay, so now let's do this question. Slide. After the class, I will arrange this, and after that, I will share it with you.
Yeah, ma'am.
Okay, so here's a question. 2 liter of a ideal gas of at a pressure, 2 liter of a ideal gas at a pressure of 10 atm expands isothermally. Okay, expands isothermally. Isothermally means here the delta U will be zero, temperature will become constant, right? At external pressure of 1 atmosphere. At 1 atmospheric pressure. So how much heat is absorbed by the system and how much work is done by the system if the gas expands to 10 liters? Okay, now let's see the question. So here, what is given? First, write down what is given over here. 2 liter of an ideal gas. So for V1, initial volume is 2 liter. And at last, they have just asked if the gas expands to 10 liter, means V2. Okay, V2 or VFP आप लिख सकते हो. That's the final volume is equals to 10 liter. And if we are talking about the isothermal system, okay, isothermally, so it means delta U equals to 0. And for isothermal, we know that Q is equals to minus W. Okay, as we have derived here. Iso Q is equals to minus W. Now, let's start the question. So W, work we know that is equals to minus P external into delta V. Okay, and the P external pressure is given, which is 1 atmospheric pressure. So minus 1 atmospheric pressure into what is delta V? So delta V equals to V2 minus V1, which is 10 minus 2 means 8 liter. 8 liters. So just substitute the 8 liter over here. So it is minus 8 atmosphere liter. And what's the value? You know that 1 atmosphere liter is equals to 100, approximately equals to 100 joule. So you can substitute it over here. So you will get minus 800 joule. So work here is minus negative 800 joule. Okay, and negative means the work done is by the system. Okay, by the system हो रहा है ये work done. Now it's a work done. Now the question here is how much work is done by the system if the gas expands here. Okay, now again another question was there. How much heat is absorbed? You have to calculate the heat, amount of heat also means Q भी आपको निकालनी है, right? And you know that for the isothermal system, Q is equals to minus W, right? So Q will be equals to minus of W. Negative तो पहले से ही है, and the W is again what negative. So minus 800. So the Q will be positive. Plus plus positive. Oh, sorry, minus minus, it will become positive. So it will give 800 joule. Okay. So 800 joule of heat, you can write down 800 joule of heat. What does plus sign means over here? Q is positive 800 joule. So what does this mean? Anyone? If Q is positive, so what does this mean?
Mom, that heat,
It is absorbed, right?
yeah, heat is, yeah.
Yeah, so 800 joule of heat is absorbed by the system. By the system. So now you should know if the Q is positive, if the Q is negative. So what does this mean? If the work value is negative, so what does this mean? It's work done by the system. So that's why the value is negative. Next, okay, is the continuation part of this question. So in the same question, just calculate the work done if gas expands in vacuum. If the gas expands in vacuum, then calculate the work done. So if gas is in vacuum, so here P external will be 0. Okay, if the work done, if gas expands in vacuum, vacuum में P external क्या होता है? 0. Okay, it's 0 in vacuum. So you know the formula, W is equals to minus P external into delta V. So just put the value and you will get 0. Okay, so because the value of P external is 0, so when you multiply it by delta V, so it will also become 0. So W will become 0. W will become 0. So at last you can write in vacuum. Vacuum means free expansion. If the gas expands in vacuum, so this phenomena is known as free expansion. Free expansion. So in vacuum, work done by the system in expansion is 0. Is 0 work done. Okay, and in vacuum means it's a free expansion. So free expansion. Got my point?
Yes, mom.
Okay, next one. Calculate the work done if expansion takes place reversibly. If the expansion takes place reversibly. So you should know reversibly की conditions क्या होती. So if the yeah, you know, reversibly we have derived a formula for the, yeah, this one. Yeah, here's the formula. So you will use this formula. W reversible is equals to minus 2.303 nRT log V2 upon V1. So this formula you will use. So again, this is a continuation part. So here you will take the volume 2, okay? And the initial volume is 2 and the final volume is 10. So you will take that only. So what is the formula? First, write down the formula. W reversible is equals to, so that's why I just told you all formula is very, very important. So just remember each and every formula. 2.303 nRT log V2 upon V1. Now, according to ideal gas equation, PV equals to nRT. So can we substitute nRT can we substitute PV in the place of nRT? Yes, we can. 2.303 into, we can just write on PV log log here. What is V2? V2 was, see in the question here, what was V2? So V2 was 10 and it was 2. 10 and 2, right? 10, V2 was 10 liter and V1 was 2 liter. Now substitute this 10 upon 2, so it will give you 2 5s are 10, log 5. Now PV, pressure was 10 atmospheric pressure, I think. Yeah, pressure was 10. Initially see 2 liter of an ideal gas at a pressure of 10 atm. Okay, so known pressure was at this temperature. So you will take this temperature, this pressure and this volume only. Okay, because it's known. आपको पता है कि इस वॉल्यूम पे ये प्रेशर है, so you will take that only. Okay, because finally at final volume you don't know what is the pressure. So you will take this 2 liter and this pressure. Okay, and you can substitute it over here. So P minus 2.303, and what was P? This is point. Yeah, pressure was 10 atm, right? So 10 multiplied by what was the volume initially? So 2 into log 5. So it's 20 multiplied by 2.303. 2.303 multiplied by 20 multiplied by, so the log 5 value, just remember that log 5 value hoti hai 0.69. 0.69, so you just take it as 0.7. 0.7. So that's the log 5 value, 0.7. Now just multiply it and just tell me the value. So I think that was in atmosphere liter, right? Volume was in liter and the pressure was in atmosphere. So this was in atmosphere liter. So when you multiply it by 100 joule, okay, because you know 1 atm liter is approximately equals to the 100 joule. So you can just substitute it over here, 100 joule. So atmosphere liter has been converted into joule now. Now just calculate this and you will get the value of work done. So when you multiply this, 1, 2, 7 twos are 14. So you will get minus 230 into 14. And after that, you will get 14 threes are 0. 14 threes are you will get 3220. So your final answer is minus 3220 joule. W reversible. So again, work done is by the system, not on the system, by the system. Okay, so you know reversible process में क्या होता है? The work done is by the system because the volume of gases, because gas particles try to expand. Okay, and in the expansion process, what happens? The gas particles work. So here the work done is by the system. So that's why the value of work done is negative. The value of work done is negative. Okay, one more point you can add. Maximum work जो होता है, it is done in the reversible process. You can see the value. Okay, value is quite large. So maximum work is done in the case of reversible process. Okay, just write on this point. So is it clear?
Yeah, mom.
Okay. Now see, we know the formula of the change in internal energy is equals to Q plus W. Okay, and W का another formula क्या होता है? W is equals to minus P external into delta V. So can we substitute this? Yes, we can. So another formula of delta U equals to Q plus bracket में minus P external into delta V. Now there are some cases over here. First case, if the expansion, because we are just talking about here, the formula was very basic, Q plus W. We were not talking about the pressure of gases. Okay, so pressure की जहाँ पे बात होगी वहां पे क्या बात होगी? Expansion की. Okay, we just talk about the expansion. So when we substitute this minus Px into delta V to this W, so here there are some cases. So here we will talk about some expansion process. First process, isothermal. If it is isothermal expansion, so isothermal means isothermal means the temperature is constant, right? And expansion. So if isothermal expansion is that expansion in which the temperature is constant and temperature constant होता है, and expansion में you have seen there delta U की value क्या होगी? 0 होगी, and the Q की value होगी minus W. We have already discussed over here. Yeah, here. Here we have discussed that. Yeah, in this chart, in this table, in this notes, we have already discussed that. Right? Q की value is minus W if if the piston is flexible, right? And the temperature, if the piston is flexible, the temperature is constant and it is isothermal process. And in the isothermal process, the change will be zero, constant ho jata hai, internal energy change, and the Q becomes equals to the minus W. So the work done is by the system in the case of isothermal. Okay, see, this is again important for the numerical part. You should know what does this mean. If there is an isothermal expansion, so it means that delta U की value is 0 and Q is equals to the minus W. So if you know the meaning of these words, then only you can do the numericals. Yeah. So first one, isothermal expansion, temperature is constant. Delta U की value 0 and Q is equals to minus W. फ्री एक्सपेंशन के ऊपर हमने डिस्कस कर लिया. सो इन द फ्री एक्सपेंशन द एक्सटर्नल प्रेशर इज जीरो, and if external pressure is zero, W becomes zero, and if W becomes zero, so when you put the value of W over here, which is zero, so delta U will equals to the Q, heat. So the change in internal energy, it becomes equals to the heat. Okay. Third one, isochoric expansion. Isochoric means the volume becomes constant. So volume की value क्या होगी? Zero. The change in volume becomes zero. And if the change in volume becomes zero, so W will become zero. And delta U, the change in internal energy is equals to QV. So see here in this equation, if the value of delta V इसकी zero हो जाएगी, it's zero. So what will happen? Delta U equals to Q. Okay, Q. Why I have written V over here? So Q at constant volume. Q at constant volume means we are just talking about the isochoric expansion. Okay, so here the volume becomes zero, W becomes zero, and the delta U equals to QZ. Fourth one, adiabatic expansion. So adiabatic means there is no exchange of heat, so heat becomes zero. If heat becomes zero, then delta U equals to W adiabatic. Work done is adiabatic work done. Okay. Isobaric, isobar means pressure will be constant. So in this case, isobaric process or isobaric expansion. So here, basically, we will not talk about the expansion over here. We'll talk about the isobaric because expansion किस term में होता है when there is a pressure. So if here the pressure is constant, so why we talk about the expansion over here? So we will talk about the process, only process, isobaric process. So isobaric process में क्या होता है? P external is equals to constant. External pressure becomes constant. And if external pressure becomes constant, so here this whole thing will become constant, zero. Okay, and delta U equals to Q. Okay, and because we are just talking about the at pressure, uh, constant pressure, so that's why I have written QP, the heat at constant pressure. Heat at constant pressure. Okay, clear to everyone? Each and every point?
Yeah, mom.
Okay, now it's a enthalpy. It's a enthalpy. The heat change. So what is enthalpy? Enthalpy को हम किससे denote करते हैं? Capital H, right? So capital H is basically enthalpy. And the question is, what is enthalpy? So it's a heat change between system and the surrounding at constant pressure. At constant pressure, the heat exchange between the system and the surrounding is known as enthalpy. Okay. So basically, what is we have this equation according to the first law of thermodynamics. We have delta U equals to Q plus W. So at constant pressure बात हो रही है, so heat will be you can QP लिखोगे. Okay, the heat at constant pressure QP plus W will become minus P delta V. Minus P delta V. Okay, according to this formula. It's minus P. If P external होता है basically, so external pressure is again a pressure, so you can just write off P. Okay, next one, because QP is basically, here we will talk about the exchange of heat. Okay, because we are just talking about the heat exchange. heat exchange. So we can write the QP at constant pressure. QP को हम क्या लिख सकते हैं? Delta H. Because delta H क्या होता है? It's the heat exchange. The exchange of heat. Heat ही का तो exchange हो रहा है at a constant pressure. So in this equation, we can substitute this QP as delta H. Okay. So when you substitute this, so delta U equals to delta H and plus minus, it will the bracket will open and it will become plus minus minus and P delta V. P delta V. Okay. So here, when you rearrange this, so delta H, the enthalpy क्या हो जाएगी? Enthalpy change will become delta U plus P del V. P delta V. That's the enthalpy change equation. Enthalpy change, the difference in the enthalpy, change in enthalpy is equals to change in internal energy plus the product of pressure and the change in volume. Okay, so that's the formula, that's the equation. Now, let's derive some